So here it is, the long-awaited video. Hopefully it comes to you in time to help you with some of the questions at the end of the homework that you may not have been able to do. So, right, this is where we ended off in class. And like I said, the next section on through the handout is an alternative way of representing regions with numbers and helping you determine union and intersection. But as I said to you in class, I really don't think most of you will need it. I think you can just follow the technique that I'm going to give you. Let's jump in, maybe not that one, we've done it before, though we didn't do the Venn diagrams. We did the set notation. How about this one? Probably a good one to jump in at. So here we go. We've got our universal set, 0 through 16, perfect square numbers, multiples of 4. Represent that in a Venn diagram. I think we could go straight into the Venn diagram. There will be intersection. There are perfect squares which are multiples of 4. So we draw our Venn diagram like that. And I think we can start with the perfect squares. We'll put in E, this is F, this is U. Put in E all perfect square numbers, and if they are also multiples of 4, we'll put them in the intersection region, which is right here. So 1, 4, 9, 16. That's the way that will go. Now, the remaining multiples of 4, so we get 4, 8, which is not a perfect square, 12, which is not a perfect square, 16. And then we need to add to our diagram the remaining integers, positive integers, between 0 and, or sorry, not between 0, between 1, because it's positive integers, and 16. So 1, 2, 3, 5, skipping 4 because 4 is there, 6, 7, 8's there, 9's there, 10, 11, 12's there, 13, 14, 15, 16 is there. Done. Identify the set E intersection F. So the question is, how do we want to do that? Do we want to write out set notation, or do we want to shade? I'm going to do both, and I'll be clear in a quiz which of the two or both I want you to do. So first of all, identify E, F. There's E and F. Not that clear, but if we put it in set notation, it is the intersection, which is 4, 16. And then identify the set which is not F. Well, this is the set of everything that's not 4 and 16. So there you go. And the number, oh, hold on. Yeah, is that right? That is the intersection, and this is the complement, not the intersection. Good. So then the number of the union of E and F, 1, 2, 3, 4, 5, 6. The union is everything. In the union, you include everything in both parts. And the other way that I'd kind of like to do this right now is just shading in. E intersection F is going to be here. The complement of that, so let me do it this way. Yeah, that will work. The complement of that is everything else. Both the set notation that I just did above and this can be useful. All right, we have to do this one for sure, too, because this is an example of 3 sets which may overlap. So in this case, a nice big box and 3 overlapping circles. You'll get used to drawing them. And I'm in the same boat as you with this new iPad. Could have been worse. So what do we got? The universal set and G, H, and I. Or J. Say that they want you to represent this in a Venn diagram, and it might be easier to do that first, in fact, and then to do A after it. So that's what I'm going to do. So I'm looking for overlap here. I'm looking for numbers that overlap in all 3, and I'll put them in here. So overlap. You know what, and here's where I'll fast forward the video, but basically I can see one already. I can see that 2, no, can I see? 4, 4, 4, 4. Now I'll look for numbers that are in 2 sets. 2 in G and J. Overlap between G and J. 7 is in H and J, but not in G. So H and J, but not in G. So 7. Is there any other overlap? 3, G and H. G and H, but not J. G and H, but not J. 3. And then the remainder for G. The remainder for H that are in neither. Probably a good idea not to make them look like one number. And -2 and 6 in J, and no other. So identify, now it's just easier. It's easier, I think, to see from the Venn diagram the intersection of G, H, and J. I'm going to do it in green. 4 is the only one which is in all 3. Yeah, let's do 2. G intersection H. G intersection H. I think what I'll do with this one, in my diagram, you could do separate diagrams if you really needed to. But in this case, HJ. For J, I'm going to use this line. Okay. And G intersection H. I can still follow that. I hope you can. And G, J. And obviously these are going to be a lot more clear if you do them on separate diagrams. But yeah. Now I'm going to do determine union. G, well, it's not union, it's the complement of the union, so it's all 3 of them. But in fact, not all 3 of them. everything that is not all three of them. How about that? Finally, kind of a tricky one, especially doing it all on, and actually they're not asking us to draw this on a Venn diagram. So I'm just going to do this last one here through looking at the set up above, the sets up above. So what are we looking at? We start internal and work out like always with any order of operations, which includes parentheses. So G intersection J. I can use this to look. G intersection J. This looks like it's 4 and 2. Now we're looking for an intersection not H. So not H. Not H is, and again, easier off the Venn diagram, I think. Although it just occurred to me, did we get all of the elements up here? -4, no we didn't. So that was good to pick up before the end of this, that anything that is not in G or H or J is in the universal set. So -4 is there, -3 is not, -2 is there, -1, 0, 1 is there, 2 is there, 3 is there, 4 is there, 5, sure that looks like a J, 6 is there, 7 is there, 8 is there, and that's it. So not H, so everything outside of H, everything outside of H, -4, 1, 2, -2, 6, and all the others. All right, there's a lot there, a ton there, and I did it all in one diagram. Probably it's better done in separate diagrams. So here we go through these. So this is where these set pieces are a little bit tricky, but logicking your way through, I think you should be fine. And shading. And if you just have a pencil with you, you can do it. I'll just do these two with the fine pencil. So we're saying not A. So everything that is not A. Shading with a pencil. Not A. And B. I'll just draw lines this way. And so the intersection, I'm going to draw lines the other way. The intersection is that which is both. And I guess I could just be clear with that. C union D, well, that's pretty straightforward. So again, pretending you just had a pencil and you could shade. It's both. It's all of C, oh, and not D. Oops, so there's C anyway. So I'll do C that way. I'll do, sometimes it's hard to see that. Do not D with my lines going one way. Not D. All right, and then the union of both of them. So we go the other way again. Everything that I just shaded either by rubbing my pencil or by doing right directed. So what we've got here now is we've got C, which is the gray, not D, which is the lines. Union now is what we're looking for, so I'm going to try to draw this with a color pencil. Union is everything. Like that. As good as it would be to be able to do this with just a pencil, colored pencils would be much better. So I'm going to do this with colored, whatever this is. So E intersection F, but not that. So let's do E intersection F first of all. And okay, so I'll use the red. That's that. And now we're saying not. So I'm going to make my color green to be the full result. Okay. Same idea over here with not G unioned, this time with not H, G complement, union, H complement. Let's start with the not G and the not H. And I'll start with maybe the red. Not G. Well, it'll have to do. Not H. What color would be good for that? So not H. Everything outside of H. So, well, anyway, it's union, so it's everything. So let me switch just to doing lines. It's everything, everything except for, curiously enough, and this is a neat computer science. It's almost like De Morgan's law, I think, something like that. Anyway, I'll think about that, tell you later. But for now, it's everything. So everything, because we're unioning the two. So something like basically everything except for where it's both. All right, for these ones, the first thing that I've done is I've copied over each of them, because what I plan to do is put my final answer here. Frankly, with the iPad, I think I can just do it with the tools now that I figured out how they work properly, but you might want to just mess around trying to figure this out the surefire way with pencils, colored pencils and shading and so on, and then when you got your answer, transfer it because it's going to be pretty messy. But not if you use an iPad, because watch this, watch what I figured out in the past 10 minutes. So we're going to start inside with B union C. B union C, I'll do that color. And what I've learned in the past 10 minutes is not to lift up my stylus. B union C. And then I don't have that overlapping that I've been getting to the video to this point. Isn't that nice over that? There's B union C, all of B, all of C. And straightforward now, so I'm looking for A intersect. So all that is A, I mean I could do A, why not? Let's just do A. Let me do A. Here's A. A is all of this. Now, because of the way I figured out my iPad, check this out, right? Now you just get a nice solid color in A and the overlap, you can see it. There it is. the intersect is that color. So I'll go down here. Let's give it another, maybe a final color, maybe not the same color. Red for final. I also figured out this. If you want to make it darker but uniform, you lift up and then you go over all of it again. And again, if you want. Isn't that nice? There it is. There's the answer. Oops. Next. Well, I'm going to start with the not y. We could even start with the 1 and then do the not, but we know what not y is. So let's get some more colors here. Not y. Not y is everything in the universal set that is not y. I'm going to lift up my stylus. Isn't that nice? So there's not y, more or less. Now we're looking for x intersecting with it. So x intersecting with not y will be all that is x, and is also what we just shaded. And now we're looking for the final, so we're dealing with this. So this is what I've just shaded in union with z. Pick a completely different color. In union with z. All of this, there it is, and all of z. So all of this and this is where this falls apart a little bit. I'm just going to have to remember what's what. All of z. What I can do, I think, is just darken up. All of, we first figured out, plus all. I don't know if that's any better or not. All of z. Well, I was on a roll there. That's it. So that's what I'll do. So I'll go down here and I'll put my final answer. This is a kind of schmancy one, this one. That's it. That's a good one. That's a really good one. Identify each of the shaded regions, but not B. So it's all of A. Right, for this one, the first thing you gotta see here is that we're dealing with an intersection. We're not dealing with a union because there's stuff that's excluded. So like, that's excluded. So it's all of A. It's for sure it's A. And not B. It's everything that's not B. So it's intersection, not B. Because not B is all this. And A is all that. So that which is both is what's shaded. Not together, but both overlapping. Is A. And I think 2 is a little bit easier to see. That we've got the union of C and D. not, the complement of it. That was fairly straightforward. Well, it's what it is it's A intersect B, but not C. So A intersect B intersect not C. Let's see if that makes sense. Because it is not C, it's also the intersect of A and B. That's my answer. That's my final answer. In this one, what do we see over here? Y union, so with all of Y, we also have this. What's this? This is the intersect of X and Y, a part of it. You know, we got a union of this and this. Y and the intersect of X and Y. I'm not going to guarantee that all these are perfect. By all means, come back at me with argument. I don't know if there are answers to these in place, but that's it. Hopefully. And the other thing to mention here, just in person as it were, on the video, is that this was a lot. So let's just see how it goes with the homework, and we'll talk tomorrow in class.